Let's look at an example of a scheme program that draws Sierpinski's triangle, using lots of the features of scheme that we've seen so far. When you start scheme, you can immediately start adding numbers together. But there's also some built-in drawing facilities in the version of scheme that we distribute with the homework assignments for this course. So, for example, you can say move forward 100, and this forward procedure tells a little turtle to walk forward 100 units. Let's rearrange a bit so that we can move the turtle some more. Other commands include turning right by 90 degrees, going forward again, or in fact, you could also go backward. And the turtle can not only turn right, but also turn left. Now all of this interacts with the scheme language that we've already defined, so I could build a procedure to draw a line that moves forward 50. And then I can draw a line, and another line, and take a right turn. I could also define a procedure that does something twice, by doing it once and doing it again. So if I twice draw a line, then it'll draw 2 lines. And all of this could also be stored in a file. Now typically what you store in the file are the procedure definitions. So there's what a line is, there's what twice is. Perhaps not just twice, we'd want to repeat something many times. Repeat k times some procedure means calling that procedure, we're going to do it at least once. And if it's the case that k is greater than 1, then we have to keep going. So we'll repeat k minus 1 times using that same procedure. I could load all those by naming the file. Then I'll take a right turn to point ourselves down, and we can repeat 3 times, drawing a line. Or twice more, we could draw a line. Or we could repeat 5 times some custom procedure that we define using a lambda expression. Repeat takes a procedure of 0 arguments, so I say lambda takes 0 arguments, and each time it's called, I'd like to go forward 50 and then take a right turn of 144 degrees. Cool. Let's quit and start over so we get a fresh canvas. Now that I can repeat, I can draw, for example, a triangle. But I don't want a triangle that's just a boring old triangle that always has a line as its edge. I want an arbitrary edge. So I'll use a function to define what it means to draw the edge of the triangle. But the triangle always involves repeating 3 times a procedure that first draws the edge and then takes a turn of 120 degrees. So if I load this file and draw a triangle with lines as the edge, I'll get a regular triangle. But I'd like to draw Sierpinski's triangle. Let me tell you about Sierpinski's triangle. Sierpinski's triangle has some recursive depth, d, and also some side length, k. It's a triangle, but drawing the edge of this triangle involves making a choice. If d is 1, then we just draw a line of length k. Otherwise, we draw a leg of Sierpinski's triangle with d greater than 1, which is going to be mutually recursive with this procedure Sierpinski that I've just defined. The leg also takes in d and k, but it does the drawing work. And here's what it looks like. You draw Sierpinski's triangle, but half the size, and with a depth of 1 less. Then, without drawing a line, you move to the end of where this leg should go, which means you have to pick your pen up, go forward k, and then put your pen back down so you can draw some more of Sierpinski's triangle. So I'll quit so I can start fresh. Start with a 90-degree right turn. Set the speed of the turtle to 0, which is as fast as it goes, and then I can draw Sierpinski's triangle of depth 5 with side length 200, which will work much better if I actually load the file defining what it is, and then it will start to draw. So each little triangle you see is the base case. If d equals 1, then it just draws a triangle using a line. Otherwise, it builds a triangle out of Sierpinski triangles. A Sierpinski triangle is made up of 3 Sierpinski triangles, each of which is made up of 3 Sierpinski triangles, each of which is made up of 3 Sierpinski triangles, each of which is made up of 3 regular triangles. We finally hit the base case. And of course, if I went back 200, then I could draw an even bigger one. But it's going to take a while. You're welcome to skip to the next video if you don't want to watch it draw, but some people like watching it draw, and so you're welcome to do that as well. Yes, right now it's redrawing Sierpinski's triangle where I drew it before. The turtle doesn't keep track of what it's drawn before, and so it doesn't know that it's doing redundant work. But now, finally, it's completing the job. You'll notice after it finishes drawing the last little triangle, it's going to work its way back to where it started by completing all the pen up, forward, pen downs of all the different recursive calls along the way to creating this image.